So in the last video, we calculated what is known as a confidence interval. So in our previous example, the 95% confidence interval was x bar plus or minus 0.8, which was 2 times our standard deviations. Most confidence intervals have a form similar to this. We've got our estimate plus or minus our margin of error. And the margin of error is a number that's added to and subtracted from a statistical estimate to define our confidence interval at a given confidence level. So this was the 95% confidence interval. We could have done a 99%. I wouldn't recommend doing anything like less than 95, like 90%. That doesn't typically feel good, like gut instinct wise. So a level C confidence interval for a perimeter has two parts. An interval calculated from the data, which has the form estimate plus or minus margin of error. A confidence level C, which gives the probability that the interval will capture the true parameter value in repeated samples. So we had a confidence level of 95% before, so 95% of those intervals would contain the true population mean. Our confidence level is the overall capture rate if the method is used multiple times. So our sample mean will vary from sample to sample, we've seen that, but when we use the method estimate plus or minus margin of error to get an interval based on each sample, C% of these intervals will capture the unknown population mean. So, how do I interpret a confidence level? Well, the confidence level is the success rate of the method that produces the interval. We don't know whether the 95% confidence interval from a particular sample is one of the 95% that capture mu or one of the unlucky 5% that'll miss. So to say that we're 95% confident that the unknown mu lies between 26.4 and 28.0 is shorthand for we got these numbers using a method that gives us correct results 95% of the time. And that feels pretty good, right? That's like 1 out of 20, right? So here's an example of a confidence interval illustrated. Okay, so I have my population. We don't know our population mean, but we do know our population standard deviation. That was one of our simplified conditions. So if I take 3 samples of 936, I get a mean of 27.2, 27.4, 26.8. So I get many confidence intervals and 95% of these confidence intervals will capture the unknown mean of our population. So another illustrated version of this confidence interval would mean that if I have a sampling distribution of my sample mean and I took 95 intervals, okay, that only 1 out of 20 would miss having the mean within our confidence interval.